Hello, one. So this is another MATHCOUNTS national target round problem. So this was number 8, so which meant to be the most challenging question on the target round. Okay, so we have a set S, okay, with a positive integer. None of them are actually consist of a prime factor that is larger than 20, and the greatest common factor of any two different elements in this set is larger than 1 and is not divisible by the square of any prime number. Okay, what is the largest possible number of elements in this set? So the first of all, like it's not really obvious like what they are asking at first if you are not really reading carefully, which is why I ask you to stop the video and just read it and make sure you understand and try it and get something if you can. And if you don't mind, just share with me in the comments. I just like to know what people are actually getting as their answers. Okay. So that is something I'll let you to try for sure for any question, but especially for this question, go ahead and try and see what you have. Okay, so let me read this one more time. Okay, it says we have a set of positive integers, and then none of which has a prime factor larger than 20, which means the number that I will have in that set will be multiple of some prime numbers, right? 2 to 19. Because if I have something like larger than 19 as a prime numbers, my number will have a prime factor which is not accepted. So let me list those numbers first. So 2, 3, 5, 7, 11, 13, 17, and 19. So we have 8 prime numbers that we can actually use to make that set, okay? And the largest common factor of any two different elements in this set, so let me write that as well. So let's say GCF or GCD of two numbers shouldn't be 1, and also not divisible by the square root of any prime number. Okay, so GCF shouldn't be divisible by square of a prime number. Okay, what is the largest possible number of elements? Okay, this is what we want. So the largest possible number of elements in that set. Okay, so let's kind of understand what's being asked, right? So we are trying to find a list of numbers, a bunch of numbers basically, and that will satisfy a couple of conditions. One of them is whenever you pick any two numbers in that set, then they should have at least a common divisor, okay? So that they shouldn't be relatively prime whenever you pick any two numbers, okay? And then any two numbers that you pick, like the divisor, shouldn't have any perfect square like the divisor, okay? So that's another restriction. Okay, so let's take a look at some example. Maybe that might help us to see what we are gonna look for. So let's say we take all of these numbers, and then let's multiply these. Okay, so 7, 11, 13, 17, 19. Let's take this as a number in that set. If I take this number and take any other numbers in that list, let's say 2, 3. So then GCF of this number, like whatever we get with this product, with these two products, will not be 1. That will be 2 times 3 at least, right? Because I have 2, 3, 2, 3. So that will be 6 my GCD, which is not a perfect square either. So which is why this is like acceptable. Or you can have something like this. You can just have only one of them. Like you can have 2 right here and like all the numbers right here and stuff like that. So what we want to do, we want to achieve a lot of different ways. So we can take all 8 numbers, which is I just kind of list them, or maybe I can take 7 of those prime numbers instead of 8 of those, right? So what is that supposed to look like? Like when I take 2, 3, 5 all the way to the 19, that's all the numbers. Maybe I should have written as a product. Okay, so let's take 2, 3, 5, 7. Okay, all the way to the 19. This number, this huge product, and let's say 2, 3, 5, 7, all the way to the 17. So when I multiply these 7 numbers by these 8 numbers, right? I will see that both numbers has a lot of common divisor that is larger than 1. And then I just exclude 19, but I could exclude 17. I could exclude any of those prime, which will give us the same result. So that means I can choose all these 8 numbers. That will be one of those numbers in that set, which will be 8 choose 8. Okay, I can choose all of these 8 numbers. And then I can choose any 7 numbers, because when I choose any 7 numbers, we will have 7 common numbers with those 8 numbers, which means they will have a common divisor other than 1. So I can choose 7 of those. Or I can choose 6 of those, not like we don't have to choose all 7. So we can choose any 6 of those, which will be 8 choose 6. And then we can choose any 5 of those. And then whenever I choose any 5 of these, with any 5 numbers that you choose in that 8 numbers, we will have a common divisor. Let's actually make an example. For example, if I choose 2, 3, 5, 7, 11. So we have 5 numbers. Okay, let's say this is one number. And if I choose any other 5, let's try to choose the number that we didn't choose yet. So 13 and 17 and 19. You see, we have now 3 numbers. So I just need to choose 5 numbers, right? So which means I will choose 2 more numbers for sure. Okay, so it could be any of these 2 like numbers. I can choose like 2 or 5. So this product and this product, as you see, has some common divisor. We have 2 and then we have 5. So which means I can choose any 5 like numbers in that set, and then that will give us some common divisor with all other sets that we have chosen so far. But I just like to be careful, okay, because the 4 is a bit dangerous. I will get that into next step. So let's add these guys. So 8 choose 8 just 1, 8 choose 7 is 8, 8 choose 6, 8 choose 2, which is 8, 7 over 2, which is 28, right? And then we have 8 choose 5, which is same as 8 choose 3. So 8 times 7, 6 over 3 factorial, which will be 56. So let's clear this. So if you add these, I guess that will be 78, 84, 92, 90, 93. Okay, so we have 93 ways to choose different set. And now we know they will have a common divisor. Okay, that is not 1. And also they don't have any common like square, like they are not divisible by any square numbers so far. Okay, but at the same time, I just said 4 is a bit dangerous. Let's say we choose a list of 4 numbers. Let's say we took the first 4 and the last 4. You know, these guys, if you multiply these guys, you multiply these guys, they don't have any common divisor, which means we cannot really choose 4 numbers in this list, because it doesn't guarantee that they will have a common divisor larger than 1. So which is why we cannot really go with 4 by 4. But we can do something else. We can actually do, like, we can choose 4 prime numbers. Okay, for example, if I choose, like, let me exclude this, for example. So if I choose any 4 numbers in this out of 7 numbers, 7 primes, because when I have 8 primes, it doesn't really work, because I can make a 2 different like set of 4 primes, and then I can multiply those, and then with other set of 4 primes, they will have no common divisor. So which means when you have actually a list of 8 prime numbers, you cannot really have made a 2 different set will have a common divisor that is larger than 1, because you can make that 4 by 4, which will have no common divisor, which is, I hope, clear so far. So which is why, but if I have 7 divisor, like 7 prime numbers instead, so I can make any 4. So I can just do 2, 3, 5, 7. Let's say this is my first number. And then if I choose the remaining 3, so 11, 13, and 17. So I have 3, I need to make a 4. So I can choose one of those numbers, which doesn't matter which one I choose. Let's say I will choose 5. So now this product and this product will have a common divisor, which will be just 5 in this specific example. So which is why if you want to make a list of 4 numbers, okay, you may, but you need to choose that out of 7 prime numbers. So which is why my second maybe case, 7 choose 4, which will be 7 choose 3. So 7 times 6 times 5 over 3 factorial, which is 35. So here's the thing, you know, if I want to go with like 3 set, we cannot achieve that. So I hope that is obvious at this point, because if you go with 3 primes out of 7 primes, so you can make first 3 and then another 3 primes, right? And then you have one more prime, which will make no like common divisor. So which is why it's not acceptable. We cannot go with 7 choose 3 or something like that. And the same idea, we cannot go with 8 choose like 3, because if you want to choose only 3 primes to make that number in that list, okay, so you can multiply, let's say these 3 and then these 3, that will give you 2 different numbers, but they have no common divisor. So which is why you cannot really go with a list of 3 primes out of 8 or list of 3 primes out of 7. That doesn't work because they will have no common divisor in a lot of cases, which is why we cannot accept those. But this is another case that we could have that will work out. But you know, there was one more condition which was given as the common factor of any 2 different elements in that set is not going to be divisible by square of a prime number. But which means when you have 2 different numbers in that set, they shouldn't have common divisor as a perfect square, right? But one of them could have. So what I mean by, so let's say we have a number, okay? So my number, let's say 2 squared, 3, okay, and then like 5, 7, 11, like 13, 17, 19. So let's say we multiply all of these numbers, and then let's multiply 2, 3 squared, 5, 7, 11, 13, 19, and 17. So if you take this number, and if you take this number, all of these product, no, so they have common divisor of 2, 3, 5, and stuff like that, but not 2 squared, not 3 squared, which means if only one of those prime numbers are actually perfect square, then they will have no perfect square divisor as common. So only one of them will have it. So if I like take 2 squared, not the other ones, or if I take like 3 squared, not the other one, we could achieve this restriction as well. So we could have 8 different numbers like that. And then any of these numbers wasn't counted in our previous step. So because we didn't have any perfect like square of something, we just use a prime number. So this is now different cases. So we have like this case, this case, this case, which is we have 3 different cases that we need to like think about it. So I hope that makes sense so far. So in these cases, we have since 8 prime numbers in our case, and then I can take square of any of those prime in every individual number. So I can just continue doing this way. So I will have 8 of those. So 8 numbers from this, I guess, last case. So I just need to add this guy, and this guy. So if I add those, 90 plus 5 is 98, 98 plus 2 is 100, 130, 136, I guess. Okay. So again, I hope that is clear. So if not, so probably you want to kind of slowly digest every single step and see if that make more of sense. And I just did this question this way. I hope that was clear, but if you see some other ways, maybe better approach, so let me know. But I just have this one. Okay, so I'll see you in the next